Hello everyone, welcome to my channel. This is an educational channel based on a lot of people's, mostly my heroes, who have done great research on a number of different topics and have put together fantastic theories of everything, fundamental theories on different subjects that purport to really describe how everything works. And today is video number 206 on the reciprocal system of theory from Mr. Dewey B. Larson. Mr. Larson passed away back in 1990, but for the 60 years or so before that, he worked out his reciprocal system first through a long period of inductive research where he had various suspicions about things, and he tried to apply them to a more general case. And then once that became clear, he wrote up his two fundamental postulates, and from there he turned it around and he began to operate on a deductive basis, if this then that. So he had his fundamental postulates, and he was like, well, if these postulates are correct, then this exists, then this exists, then this exists. And he basically created an entire theoretical universe about how everything in the universe operated. Wrote about 12, maybe even 15 books, many articles, gave a lot of talks. Didn't really get too much of a following, but a significant, there are a few people out there that are still kicking around his theory, including me. And the basic idea behind Larson's system is that we live in a universe of motion. The universe is not made out of matter. It's not made out of energy, but it is made out of motion. Motion for Larson is the relationship between space and time. That sets up a generalized reciprocal relationship between space and time. Motion is basically a fraction where time or space is the numerator and space or time is the denominator. And we know that that's true, at least to a limited extent. For example, speed. The car is moving at 25 miles per hour. It's 25 miles of space in 1 hour of time. Speed, space over time. I dropped the rock out the window and it fell at 9.8 meters per second squared. That is acceleration, 9.8 meters of space in 1 second per second, or second squared. And so that's acceleration. That is space over time to the second power. But really all fundamental quantities in dynamics and mechanics are relationships between space and time. But it is a bit more complicated because space and time can come in 1, 2, 3, or even more dimensions. This is what Larson calls coordinate space and coordinate time. We generally recognize space to be coordinate, having 3 or more dimensions, but in Larson's system, time also can have multiple dimensions, 3 or more dimensions, coordinate time. And then we also have what is called the clock time and clock space. We recognize space in the clock in time. Time is always getting later and later and later, but in no particular direction. So that's what Larson calls a scalar motion, a motion with a magnitude but no particular direction. But there is also such a thing as clock space, and that is where things are always getting farther and farther and farther apart. That is the progression or the flow of space. Space and time also both come only in discrete units. There is no continuity there. Space and time come in very small chunks, smaller than we can resolve, but chunks nonetheless. And exactly 1 unit of space in 1 unit of time is the speed of light. So the speed of light is 1 over 1 equals 1. So the speed of light is, in Larson's system, is the midpoint of the universe, whereas Einstein says that the speed of light is the maximum speed of the universe. In Larson's system, there is an entire half of the universe that's moving faster than the speed of light. This is what he calls the cosmic sector. And this is a sector that is pretty much foreign to us, even though we deal with its consequences on a daily basis. It's basically invisible to us. And it has the unfamiliar concepts of coordinate time and clock space. Whereas in what you call the material, he calls that the cosmic sector. And then that is contrasted by the material sector, which we are very familiar with, from which we make our observations and measurements, and so is legacy science, and they've kind of worked out all the equations and everything. And in that sector of the universe that's moving slower than the speed of light, we have coordinate space and clock time. That's something that we're very familiar with. So when you cross the boundary from the material to the cosmic sector, you cross that speed of light boundary, you basically have to invert or reverse the roles of space and time. So in the material sector, you've got 3-dimensional space and progressing time. In the cosmic sector, you have 3-dimensional time and progressing space. And that is a powerful tool because you can extrapolate. Even though we don't see the cosmic sector, we can determine exactly what's in it because we can see the material sector. And the cosmic sector is exactly the same, except with the roles of space and time reversed. Now, Larson is going to get into some of that today. We are going over his 1979 book that's called Nothing But Motion. And this is primarily a book on atomic physics. And we are about to start chapter 16, which is called Cosmic Atom Building. Okay, now we generally know a lot about material atoms. Material atoms like carbon, oxygen, nitrogen, hydrogen. These are, in Larson's systems, these are combinations of motions. You start with a photon or 2 photons at the core of all of the atoms. And these photons are a combination of 2 different kinds of motions that result in a sine wave. Now there's a little bit of a dispute as to which motions create the sine wave, because they can be created with a translational motion combined with a vibrational motion in a perpendicular direction, or they can be created by 2 counter rotations. So Larson went with the translational motion and the vibrational motion, but some of Larson's followers believe that it's actually the result of a birotation. That being said, that is a question that we will go over later. But the main point is that the photon is a simple harmonic motion or a sine wave, and that is at the core of the atom. And then you take that simple harmonic motion and you rotate it at least twice, and that creates the spherical atom. And so, but in this chapter, Larson is talking about a cosmic atom. So when you're talking about a cosmic atom, you're reversing the roles of time and space. So in the material atom, you've got a sine wave that is in time, and you've got the rotations that are in space. And then in the cosmic atom, you have the reverse of that. So So we'll start to go over this chapter, Cosmic Atom Building, in Larson's own words. In essence, the cosmic ray decay is a process whereby high energy combinations of motions that are unstable at speeds less than that of light are converted in a series of steps to low energy structures that are stable at lower speeds. A requirement that must be met in order to make the process feasible is the existence of a low energy environment that can serve as a sink for the energy that must be withdrawn from the cosmic structures. Where a high energy environment is created, either fortuitously or deliberately, the decay process is reversed, and cosmic elements of lower atomic number are produced from cosmic elements of higher atomic number, or from material particles. Kinetic energy being absorbed from the environment to meet the additional energy requirements. The first step in the reverse process is the inverse of the last step of the decay process. A neutron equivalent is converted into now, he went through the decay process in the last chapter, so you may want to refer to about the 6 videos that I did before this. A neutron equivalent is converted into one of the rotating systems of a cosmic krypton atom by the inversion of the orientation with respect to the space-time 0 points. It is convenient from a practical standpoint to work with electrically charged particles. The standard technique in the production of transient particles, therefore, is to use protons or hydrogen atoms, which fragment to protons, as the raw material for cosmic atom building. In the high energy environment that is created in the production apparatus, the particle accelerators, the proton, which is M1-1-1, and that first number is the primary two-dimensional rotation, the second number is the secondary two-dimensional rotation, and the third number is the electrical one-dimensional rotation. So that's the proton, 1-1-1. It ejects an electron, which is M0-0-1, and then separates into 2 massless neutrons, which are M1/2-1/2-0. And that's not really 1/2, it's just 1, but it's one rotation that is shared between 2 separate dimensions, each of which converts to a half C krypton atom that is one of the rotating systems of that atom. That's what I should say, instead of 2 dimensions, 2 separate rotating systems. Bidirectional inversion. These half C krypton atoms cannot add displacement and become muons because they are unable to dispose of the proton mass, which persists as a gravitational charge, half of the normal size, as the proton has only one rotating system. They remain as particles of a distinct type, each with half of the C krypton mass, 52 mega electron volts, and half of the 931 mega electron volt mass of a normal gravitational charge, the total being 492 mega electron volts. They can be identified as K mesons or kaons, the observed mass of which is 494 mega electron volts. As can be seen from the foregoing, the initial production of transient or cosmic particles in the accelerators is always accompanied by a copious production of kaons. Each of the subsequent steps in the cosmic atom building process that requires the addition of mass, such as the product of C neon, the lambda particle, from C silicon, the pion, and the product of the psi 3105 particle from one of the heaviest of the hyperons, similar to the initial cosmic particle production, except that the proton mass is added to the product as a gravitational charge instead of forming a kaon. Where kaons appear in connection with the product of these particles, they are the result of secondary processes. Okay, try to hang in there. This is very difficult. I am probably 70% lost myself, and I've read this stuff like 5, maybe more times. You may want to go back to the earlier chapters to review all of the terminology that he's using, that he assumes that you have memorized from the previous chapters. But I'm trying to present Larson in his own words, so that if a person is really diligent, that they can get it from these videos. So I'm going to just follow along with Larson and see if I can get my bearings, and hopefully you can get yours as well. So next paragraph. Furthermore, kaons are not produced in the decay processes, either in the cosmic rays or in the accelerators, because the decay takes place on a massless basis. A few kaons appear in the cosmic ray decay events, but they are not decay products. They are produced in collisions of cosmic rays with material atoms under conditions such that a temporary excess of energy is created, in miniature equivalents of the particle accelerators, we may say. If the reverse process, the atom building process, is carried beyond C hydrogen, the final particle vanishes into the cosmic sector. Otherwise, the cosmic atom building which takes place in the material sector is eventually succeeded by a decay that follows the normal path back to the point of reconversion into massless neutrons. Where the excess kinetic energy in the environment is too great to permit the decay to proceed to completion, the production and decay processes arrive at an equilibrium consistent with the existing energy level. In such a high energy environment, the life of a particle may be terminated by a fragmentation process before the unit time limitation takes effect. This is simply a process of breaking the particle into 2 or more separate parts. The degree of fragmentation depends on the energy of the disruptive forces, and at the lower energy levels, the products of fragmentation of any transient particle are mainly pions. At higher energies, kaons appear, and in the fragmentation of hyperons, the mass of the gravitational charges may come off in the form of neutrons or protons. Corresponding to fragmentation is the inverse process of consolidation, in which particles of smaller mass join to form particles of larger mass. Thus, the phi particle, with a mass measured as 1020 mega electron volts, has been observed to fragment into 2 kaons. The 36 megavolt excess goes into kinetic energy. Under appropriate conditions, the 2 kaons may consolidate to form a phi particle, utilizing 36 mega electron volts of kinetic energy to supply the necessary addition to the mass of the two smaller particles. The essential difference between the two pairs of processes, building and decay on the one hand, and fragmentation and consolidation on the other, is that building and decay proceed from higher to lower cosmic atomic number, and vice versa, whereas the fragmentation consolidation proceed from greater to less equivalent mass per particle, and vice versa. The decay process as a whole is a conversion from cosmic status to material status, and the atom building in the particle accelerators is a partial and temporary reversal of this process. But fragmentation and consolidation are merely changes in the state of the atomic constituents, a process that is common in both sectors. The change in cosmic atomic number due to fragmentation may be either upward or downward, in contrast to the decay process, which always results in an increase in the cosmic atomic number. This difference is a consequence of the manner in which the mass of the gravitational charges enters into the respective processes. For example, the decay of silicon, the pion, is in the direction of C krypton. On the other hand, the kaon, a gravitationally charged C krypton atom, cannot decay into any other cosmic particle, as it is at the end of the line so far as decay is concerned, but it can fragment into any combination of particles whose combined mass does not exceed the 492 mega electron volt kaon mass. Fragmentation into pions reverses the direction of the decay If the maximum conversion to pions takes place, 3 pions are produced. Frequently, a larger part of the total energy goes into the kinetic energy of the products, and the production of pions decreases to 2. Okay, now just keep that in mind for next time, and just kind of try to let this wash over you. You're probably only going to get a fragment of this, but if you persevere and you listen to this many times over, along with kind of mastering the terminology from previous chapters in this book, you will be able to get this. It does make sense in my experience. He's not just talking out of his elbow, but he knows what he's talking about, but he's having a little bit of trouble conveying it to people like us, because he's having to create an entirely different language, new concepts, new terms to describe a lot of this stuff. So, my advice is just to let it wash over you, and, put it into your subconscious for marination, and, you might come up with something. Might mix up with the stuff that you've already learned from past, your past experience, and you might get a gem there. All right, well, thanks for tuning in, and we'll come back to this chapter tomorrow. Hope you have a great day, and we'll see you tomorrow.